Welcome back to week 4, and in video 3 we're going to get into specifics of what clouds are and how they form. So what is a cloud? Well, it's basically a parcel of air that contains visible amounts of water droplets or ice crystals. So that's why you see this white puffy thing or gray thing in the air, because you're actually seeing those water droplets in the air that have condensed. They can be thick, thin, low, high, big, little, all different sizes or shapes. So how do they form? Well, cloud's going to form when the air parcel is cooled to its dew point. It should be familiar from last week. So dew point is that temperature at which condensation occurs. So some ways that cooling can happen. It can happen as air expands, which is called adiabatic cooling, which usually happens when you have air rising. As it rises, it expands and it cools. You can also have air cooling as it comes in contact with cold surfaces, and this is called conductive cooling. Similar to how if you put a pot on a stove to try to heat it up, the water inside, except you're cooling it, so the opposite. So how do we have our clouds forming? Well, there's a few different things. We talked about stability in the last video. That takes into account how clouds form, and we're going to mention that in some of these other ways to form clouds. So things like surface cooling, frontal lifting, orographic lifting, and thermal lifting are some of the main types. So surface cooling, this happens when you have cold land surface and you have warmer air that's damp, has some water vapor in it, that moves over that cold surface. And as that air is moving over that cold surface, the air starts to cool because of conductive cooling. That air parcel cools to its dew point, and then we get clouds forming. So here you can see that damp air moving in over this cool coastline. Here, these two images, there's snow on the ground, so the ground surface is much cooler than the air above it. And we have that air above cooling to its dew point to produce water vapor as clouds. We also can have what's called frontal lifting. This happens when you have an air mass, two air masses that collide with one another. One of those air masses is damp, has some water vapor in it, and we end up having that damp air being forced up into the atmosphere, and it cools adiabatically, so it rises, expands, cools, and we get a cloud forming. So in this case, that cooling air parcel can either be stable or unstable, so you can have both in this scenario. So here we have two scenarios, a warm front and a cold front. Here we've got warm air represented in the kind of reddish color here, cooler air with water vapor in it being forced up and over that air. And then here we have a cold front, cold air, that damp air on the other side being forced up and over that front, and have an animation here that you can also watch on your own if you wish. So here we go. It's gonna cycle through. So we've got that cold front moving in, that cold air running into the warm air, and you can see as that warm air, it's also damp, it's forced up and over that cold air, and we have a cloud forming as a result. So that is frontal lifting. Orographic lifting is very similar. Instead of air, however, forcing that air to rise, you have a piece of land, a mountain range, forcing the air to rise up and over the mountain. This is common in Hood River. It's why oftentimes when you're in Portland, it's rainy, and then you travel out to Hood River in the Dells, and it is a beautiful sunny day. This is the exact reason, because as that air is running into the windward side of the mountains, so here we have another example. We have that prevailing wind coming from the ocean, strikes the Cascades, and as it's hitting the Cascades, it's being forced up and over that mountain range. The air cools adiabatically, so it's rising, it's expanding, it's cooling, condensing, and we often get rain and precip on the windward side of that mountain range. And then as that air travels over to the other side of the mountain range, it has now basically all the moisture has been sucked out of that air, and now you have cool air that is pretty dry on the other side of the mountain range, and we end up having that air starting to evaporate any water off the surface, so we often get dry conditions on the leeward side. And that's exactly what happens here in the Pacific Northwest. Coast and Portland, really rainy, really wet. You cross over the Cascades to Hood River, out to the Dalles, and further out towards Pendleton, and you end up with much drier conditions. This is also called the Rainshadow effect. And here you can see an example of Hawaii. This is a big island. You see the yellow arrow showing you the direction that the air masses are coming, and you can see this pretty straight divided line here all along the surface of the island that I've just traced here, between the brown side over here and the green side over here. So you can make the assumption based on the green versus brown that the green side probably gets a lot more moisture, and that's the side that the air masses are coming from, being forced up and over this island, dropping the moisture on the windward side and then evaporating moisture from the leeward side. Another way we can produce clouds is through thermal lifting. This is what happens throughout the day. We have the sun heating up the land surface. That land surface then radiates heat upwards into the air. That air is then warmer, less dense. It might be slightly damp, have some moisture in it. As it rises, it cools as it rises because it's expanding, and we get condensation happening. This is also called convection. In this case, the parcel of air is unstable. We also can have low pressure and surface air convergence. This happens when you have a low pressure system moving across the land. What happens here is we've got air rising in one area. Here you can see a low pressure system, low pressure above. So the air is going to be moved upwards due to that low pressure. And then as the air rises, it expands, cools, condenses in this case. So those are our main ways to form clouds. We will come back and talk about the different types of clouds that exist.